Alright, today we got double angles and half angles. And if you want to read, you can see where the double angles came from, or the half angles, and how we use them. It's going to take me most of the class period just to get you to use these four identities. Right? So let's get to it. First of all, the double angles. Sine of 2 theta. The identity, or the formula. Sometimes in trig, rather than calling it a formula, they call it an identity. Really? Would be 2 times sine theta cosine theta. So it's a formula we can use to find a double angle. For cosine, it is cosine squared theta minus sine squared theta. Those are the two formulas for double angles. And I'll show you how they're used. Well, if you take that cosine of 2 theta, there are two other forms of this that we can use. And from the Pythagorean identity, can you tell me what cosine squared is equal to? 1 minus sine squared. So 1 minus sine squared minus sine squared would be 1 minus 2 sine squared. It's just a different form that we can use. And that's also cosine of 2 theta. 1 minus 2 sine squared theta. Because you know sine squared theta plus cosine squared theta equals 1. All right, you guys have committed that one to memory. And what is sine squared theta? It's 1 minus cosine squared theta. Remember I told you guys, if you memorize as you go, it's going to make your life a lot easier. And so cosine squared theta minus sine squared theta, which is 1 minus cosine squared theta. Distribute that negative. You're going to get 2 cosine squared theta minus 1. So you really have 3 forms of cosine of a double angle. And those are the 3 forms. Okay? Right. And I'll show you how to use that or what it's used for. You'll have a problem that will look like this. Sine theta plus cosine theta squared. And the directions might say simplify that. Okay, so let's simplify that. That does not equal 1. It is not sine squared plus cosine squared, is it? We know we have to put them side by side and use FOIL, or use a 3-step process. I taught that 3-step process to my Algebra 1 class today. Instead of teaching them FOIL, I taught them how to square a binomial. So they learned that first before they learned FOIL, and I think they're going to remember it. This one says square the first term, multiply the 2 together and double it, 2 sine cosine, and square the last term. Okay? Now, do you see anything that we could do to simplify this a little bit? Anybody see anything? Because on your homework, they're going to ask you to maybe simplify a little bit. They might tell you to write something like this in terms of one trig function. What do you see, Shel?
You could turn 2 sine cosine into sine 2 theta.
You could turn this into sine of 2 theta, yes. What else? 3?
Sine squared plus cosine squared is 1.
Sine squared plus cosine squared theta is 1. So I've turned that into one trig function. Sine of 2 theta plus 1. Okay. So as you're doing these problems, sometimes rearranging, maybe sine squared theta plus cosine squared theta, maybe you could put those next to each other to see that that's Pythagorean identity. Okay. Here's another problem. Simplify cosine of 2 theta over cosine theta plus sine theta. Simplify. Well, they want you to use these identities. And cosine of 2 theta is cosine squared minus sine squared over cosine plus sine. I can't reduce that, not in that form that it's in. Does anybody see what I can do? Agree?
Cosine minus sine plus sine.
All right, I have the difference of two squares up on top. Cosine minus sine. I'm going to run out of room. Cosine minus sine. It's a difference of two perfect squares times cosine plus sine over the denominator, which is cosine theta plus sine theta. Now I can reduce. Cosine plus sine reduce. I'm left with cosine theta minus sine theta. All right, so I've simplified that. You have a number of problems like that. Okay? So you have to be a little bit creative. Let's get back to these double angle formulas and how they may be used. I'm going to rewrite them again. Sine of 2 theta equals 2 sine cosine. Cosine of 2 theta equals cosine squared minus sine squared. Given theta between 180 and 270, given information, and cosine of theta is negative 3/4. Makes sense. Cosine is negative in the second quadrant. Given that information, find sine of 2 theta and cosine of 2 theta. Right. Well, sine of 2 theta, the formula, 2 sine cosine. Let's write down what we know. 2 times sine theta, which I don't know, times cosine theta, negative 3/4. How do I find sine of theta? Okay. How do I find sine of theta? This is from chapter 13. Hunter? Cosine is, you're right, cosine is x over r. I need sine, which is y over r. How do I find y? Pythagorean theorem. We can't forget that. X squared plus y squared equals r squared. I'm given x. I know it's a lot to remember. I understand that. 4 squared is 16, 3 squared is 9, 16 minus 9 is 7. Y equals plus or minus the square root of 7. Which is it? Minus? Plus? Minus? It's in the third quadrant, so it is minus square root of 7 over 4. So let's multiply that together. 2 times square root of 7, negative times negative is positive. 2 times square root of 7 times 3 would give me 6 square root of 7 over 16, which is 3 square root of 7 over 8, and that's a sine of 2 theta. All right. Let's find cosine of 2 theta. Formula: cosine squared minus sine squared. I mean, once you use that Pythagorean theorem, it's just putting it into a formula, and the arithmetic on it should be easy. So cosine of 2 theta would be cosine squared, negative 3/4 squared, minus sine squared, square root of 7 over 4 squared. I have 9/16 minus 7/16 would give me 2/16. So the cosine of 2 theta would be 1/8. Question yourself.
Shouldn't it be, or why wouldn't it be minus negative square root of 7?
Doesn't matter. I guess I could.
Like,
All right, we'll do that. But it doesn't change the answer. Because if I square that, it's going to be 7 over 16. Yeah. But you're right, it should have been a negative. You're absolutely right. So, tell me what quadrant the double angle is in. Why? Because they're both positive, yes. So the double angle is in the first quadrant because the sine of the double angle and the cosine of double angle are both positive. All right? Look, think of it this way. If theta is between 180 and 270, 2 theta would be between 360, that's like at 0, and 540. Okay? So that tells you it's going to be either in the first or second quadrant, between 360 and 540. But these tell you it's in the first because they're both positive. Double angles. You don't really need to know this as far as the red up here.
That's what I was saying. I was wondering, like, what is the angles? Why do you mean, like, why is that given? Because
Why is that given? Because I needed to know right here, I needed to know that if that's in the third quadrant, that this is negative square root of 7 over 4, because the sine of 2 theta, if we didn't know that, we needed it here. We didn't necessarily need it for the cosine, because it's going to be squared anyway, but I did need it for the sine of 2 theta. Okay? Let's take another example. Go with me. It's a double angle. Pretty easy to use, I think. Half angle. Hard to believe, but tomorrow we're going to finish up the trig portion of the course.
I thought we were going to finish it before spring break. Spring break is in
We are. We haven't hit spring break yet, and we are going to finish.
Well, the test review is probably going to be like 4 days long.
The test is going to be on Tuesday of next week. I was hoping to give you that test on Friday, but I'd rather have some review time because there's no rush. Is there anybody?
Tell a story for
Is there anybody in here who is leaving early and not going to be here next week? All right, that's good. If you're going to miss a day or so, it won't be too bad, but you definitely do not want to go on spring break and come back and try and take a trig test. Yes.
Any day next week?
I don't know. We're testing on Tuesday.
Oh,
If you're not going to be here next week, let me know. Are you going to be here next week?
some days
Are you going to be here Tuesday?
Yeah.
Good. We got no problems.
What are you doing?
Half angle. It look like this. That's a half angle. What that allows us to do, by the way, is to take a sine of, let's say 15 degrees, and that could be 30 over 2. Or it allows us to have a sine of 22.5 degrees and get an exact answer. Okay? All right. Well, we're going to cover that later on in the week. But let's see how this is used. The formula, plus or minus the square root of 1 minus cosine theta over 2. And that's a formula for a half angle. The formula for cosine is plus or minus the square root of 1 plus cosine theta all over 2. I mean, I think after we do the homework and after you do a few problems, that you should have these committed to memory. How do you commit it to memory? Write it out for each problem. It might seem tedious, but it's going to help you memorize. Yes, sir?
Is it supposed to be cosine? Or is it supposed to be sine theta?
No, that's the way the formulas are. All right, let's see how this works. Let's say that given theta is between 180 and 270. And sine of theta is negative 2/3. Makes sense. Sine is negative in the third quadrant. Okay. Let's use this formula. Now, this you have to know. Let's find sine of the half angle and cosine of the half angle. There's the angle, negative 2/3. Sine of theta equals plus or minus, which one is it?
Minus.
No, listen. If theta is between 180 and 270, then theta over 2 is between 90 and 135. The half angle is between 90 and 135. What quadrant is that in? Second. Sine is positive in the second quadrant. You do not have to do that for the double angle. The formula takes care of whether it's positive or negative. You don't have to bother with that. But on the half angle, to know whether we have a positive or whether it's plus or minus, you have to take that step there in red. Okay? So we do know that it is positive because the half angle is in the second quadrant. All right. 1 minus sine of theta is negative 2/3. I need cosine theta. So we have to use Pythagorean theorem again, don't we? X squared plus y squared equals r squared. Given my radius is 3. Sine is y over r. Nine minus 4 is 5. X is equal to plus or minus the square root of 5. What is cosine of theta then? Is it plus the square root of 5 over 3 or negative? Negative, because I'm in the second quadrant. So we found out that cosine of theta is negative square root of 5 over 3. So 1 minus cosine, which is negative square root of 5 over 3, over 2. And the double negative makes that 1 plus the square root of 5 over 3 all over 2. And then I simplify the complex fraction by multiplying top and bottom by 3 over 3. 3 times 1 is 3, plus the 3's cancel, and 2 times 3 is 6. And that's the sine of theta over 2. Cosine, plus or minus? Well, it's minus the square root of 1 plus negative square root of 5 over 3 all over 2. See what we're going to get? One minus the square root of 5 over 3 all over 2. And what am I going to multiply by? 3 over 3. So I have negative square root of 3 minus the square root of 5 all over 6. And this is the cosine of the half angle. That's how you use that. Yes, Scott?
How do you get the 3 over 3?
Well, because I have a complex fraction, which means I have a fraction over a number. I can't have, it's like, I've got two denominators here.
So you're just using that to get rid of the complex fraction?
Yes. I'm using that 3 over 3 to get rid of this 3, the square root of 5 over 3. I'm using it to get rid of that 3.
Okay, that makes sense.
Okay? So it just simplifies it a little bit. And that's how we use the half angle. Okay? So your homework is on page 920 to 921. Problems 8 through 13 all. 18 and 19 all. And 20 through 38 the evens. Please make sure you do all the problems. Okay? It's to your benefit.